Alright, in the inverse functions, you're going to be given two one-to-one functions, one listed as a set of ordered pairs and one as listed as an equation. Okay, so for this first problem, g, for the first function g, they're going to ask you to find the inverse of the g function, inverse g of a negative 7. Okay, so the first thing we want to do is calculate the inverse of g. So to calculate the inverse of g, when you're given a set of ordered pairs, you're simply going to switch the x and y coordinates. So this becomes a negative 7, comma 0, a 5, 1, a 7, 5, negative 8, 6, and 4, 7. Oops, a little set notation. Don't have very much room there for that. But so here's your new function. Now, if they want to know, basically this is asking what is the output when I input a negative 7. So when x is a negative 7. So here's my x value. When x is a negative 7, then I get a y value of 0 back. And that is the answer for this first part. And then they ask you for the inverse function of h. Now when you're given a function in equation format, what we're going to do is we're going to replace the h of x with y. Solve this for x. I'm just going to put a box around the x just to focus us on what we're doing here. And we're going to go ahead and add 3 to both sides. And then we want to get x by itself, so you're going to divide everything by a negative 4. So you get y plus 3 all divided by a negative 4. Now basically what you're going to do is now you're going to switch your x with your y. So this will become x plus 3 over negative 4 equals y. I'm also going to just switch sides, so I'm going to have the y on this side and the x plus 3 over negative 4 on this other side. And what we're going to do here is basically we're going to replace the y here now with the inverse function of h. So I can just rewrite this as the inverse function of h of x is equal to x plus 3 over a negative 4. Okay? Now that's the second part. Now there's one more question. It asks us to find the composition of h and its inverse when the input is a negative 1. Okay, so let's talk about what the inverse. I'm going to go through this process, and then you're going to notice a shortcut here. So let's see, this basically means I'm going to find out what h of negative 1 is. So I come over here into my h function and I replace x with the negative 1. So h of a negative 1 is equal to a negative 4 times a negative 1 minus 3. So negative 4 times a negative 1 is a positive 4. So this becomes 4 minus 3, which is a positive 1. So I'm going to replace h of negative 1 with a positive 1, because that's what we just found out. H of a negative 1 is a positive 1. So when I input a negative 1, I get a positive 1 back. Now I'm just going to repeat this process, right? So I substitute here, and now I want to find the inverse using the inverse function of h. When I input a 1 into that, what do I get back? So here's my inverse function right here. You can we'll use this right here since that's written in that form. So I replace the x with a 1. 1 plus 3 over 4. So that's going to give me over negative 4. So that's going to give me 4 over negative 4, which is a negative 1. Okay, so this is a negative 1. I should put that here. Now, if you notice, basically I'm plugging a number in to the h function. I'm composing that with the inverse of h, and I plug that into the inverse of h, and I get back a negative 1. Now remember, that's what inverse operations are. They undo each other. So we can save ourselves a lot of work by remembering that h and the inverse of h undo each other. So if I input a negative 1, I get a negative 1 back. If I input a negative 3, I get a negative 3 back. If I input a 5, I get a 5 back. Okay, so let's look at another problem. So for this g function, g is, if I want to find the inverse of g, I just switch my x and y values. So I'm going to get 6 and negative 6, 9 and 2, 4 and 3, 1 and 5, and negative 6 and 7. Running out of a little room there again. Sorry about that. Whoops, and I actually need that number right there. So when I input a negative 6, I get a 7 back. Okay, to find the inverse of h of x, I replace the h of x with a y, and I solve this for x. So I subtract 4, and I divide both sides by 3. I replace, instead of writing x equals, I'm going to replace x with the inverse of h. So this becomes the inverse of h of x is equal to, oops, sorry, I should have switched my x and my y first, right? So this becomes x minus 4 over 3 equals y. Replace y with h of x. Okay, so I get my inverse function. And when I input a negative 2 into the composition of h and its inverse, I get a negative 2 back.